Hi and welcome back to another lesson in the physics video series. Today we will be discussing graphing compound motion. Compound motion is very simply using all of these different columns to create a picture for multiple kinematic behaviors. Alright, let's get started. Here's a problem that I've created for you using 5 pairs of graphs. These 5. Sketch the corresponding dt and vt pairs for a given sequence of motion. So I've created 4 motions, regions 1, 2, 3, and 4. For example, here's a particular problem with numbers that we'll work on. The car waits for the first 4 seconds. Then the car starts from rest and accelerates for 4 seconds. Then, in step 3, from 8 to 12 seconds the car travels at a constant speed, and from 12 to 16 seconds the car decelerates until it stops. We're going to draw a distance time and velocity time graph pair for each of the 4 behaviors. So if you recall this particular chart, whatever dt graph behavior you pick, you must pick the VT below it. There's no mix and match. The distance time picture in the DT row must correspond with the velocity time picture below it in the bottom row. Let's take a look at how that graph's going to work out. So in region 1, which corresponds to the first behavior, the car waits for the first 4 seconds. So that means that a car that's waiting is at rest. And if it's at rest, as time ticks away, it has no change in displacement. That can be seen by this graph in column 1. And its matching pair, VT graph, is a 0 slope, 0 acceleration VT graph. In region 2, which is number 2, the car starts from rest and accelerates for 4 seconds. Now we're not naming the rate of acceleration, but we just need to know that the car is accelerating. So we know that in region 2, we have to have an accelerating graph. An accelerating graph is in fact this 4th column. It's the parabola, and the change of speed time graph must be the constant positive slope. In region 2, we have the dt parabola in region 2, and in the vt region 2, we have the constant positive slope. Number 3, from 8 to 12 seconds, car travels at a constant speed. We look at region 3, and we know that we need to have a constant speed in region 3. The dt graph for a constant speed is column 2. It is a constant slope. dt slope is speed, and its vt equivalent is a 0 slope, no acceleration, for constant speed, line above the t-axis. This green line is a constant slope, dt, the slope is v, and this is the vt graph, and its slope is a, and this a is 0. There is no slope because it is not accelerating. So the car from region 2 to region 3 accelerates, and then it reaches a certain speed, and then it maintains this speed. And that's what you see down here below. In the VT graph, we have a constant slope, which is a value of acceleration, and then we have no slope. So it accelerates going from a 0 speed to some speed, and then it holds that speed. Now in the 4th region, from 12 to 16 seconds, the car decelerates until it stops. We can see that the VT graph for deceleration in the forward direction is a negative slope with a downturn parabola, just like we see in column 5 right here. The slopes, these little individual tangent lines, get flatter and flatter until they are horizontal, meaning that the slope of speed decreased to 0. Then the VT equivalent, you have a speed, and over time that speed value decreases until you have 0 speed, and this is what you see in region 4. And to summarize, we'll look at the entire compound motion of this graph. In the dt upper row, we see a 0 slope, an increasing slope, a constant slope, and a decreasing slope. 0 slope means 0 speed. An increasing slope means an increasing speed. A constant slope means a constant speed. And a decreasing slope means a decreasing speed. So the 4 conditions above are drawn in the 4 regions here below, and they have their equivalent VT expressions. 0 speed, no acceleration, so you have no acceleration in region 1. In region 2, you have an increasing speed, which means acceleration, and here you see the steady slope of increasing speed. In region 3, you have a constant speed, and when you have a constant speed, you have a zero acceleration slope. And in region 4, you have a decreasing slope, which means a decreasing speed, and that's what you see here with a negative slope. Alright, this concept of compound slopes comes up in some of the region's questions where they put a few of these pictures in a row and ask you to describe what's going on. I hope you enjoyed this video. Thank you for watching, and I'll see you in the next video.